All right, good morning, everybody. It's great to see a really packed house in here. It looks like standing room only. We're really excited today to talk to you guys about Android Wear. I'm Austin Robeson. I'm a product manager with the team.
And I'm Justin Coe. I'm an engineering lead on the team.
Excellent. And we have been so thrilled with the excitement that we've gotten from you guys throughout the rest of the conference. I think the third floor area where the devices are out there has been mobbed the entire time that I have walked by. So thank you for all of your support, and we're really excited to talk about what we're doing with Android Wear. So I wanted to start with a quick overview of what Android Wear is all about, and then we'll dive into some code and really show you what it's like to build applications for Wear. So we all love our smartphones. They're rich and engaging, and they can deliver these really deep, engrossing experiences. But I think this is a picture that we can all relate to. Sitting around, we're all focusing on our phones and not on the people around us. So technology can be distracting, and here's where we saw an opportunity with Android Wear to make this better. Android Wear delivers information just when you need it, and just in a glance. And really, that means you can be more connected to the people around you and the people who aren't with you at that time. So if you look at that in a timeline, this is something that I think we have all experienced. You feel your phone buzz in your pocket, you pull it out, and you're like, okay, well, I got some email notifications here. You go to your inbox, and next thing you know, you spend several minutes distracted from the world around you, really engaged with what you're doing, but not necessarily present with what's going on. So with Android Wear and having these glanceable notifications on your wrist, you can have more interactions throughout the day, have them shorter and less distracting from the world around you, but still get more information about what's happening. So to deliver this new interaction model, we created an entirely new UI. And what that is a vertical stream of contextually ranked cards. So you have the most important information for you at the top of the stream, ready for you to glance down and take a look at it. This is completely automated from an Android perspective of having your notifications bridged across. It also has Google Now cards, and importantly, has your third-party content, which is what we're going to be talking about today. So earlier this year, we launched a developer preview that allowed you to get started experimenting with your apps of what it would be like to bring your experience to the wrist. So this allowed you to take your notification objects on your phone and really be able to augment them to have additional pages of information, to be able to bundle these things together in stacks, and to be able to have voice replies. So what we're making available today is an SDK that allows you to extend those experiences even further, where you're running code directly on the wearable, using all of the familiar Android tools that you're already used to using. So we're going to introduce a few APIs that allow you to send data back and forth between the wearable and your phone, as well as generate custom UI and integrate with voice actions through intent filtering, just like on the phone. So we've been battle testing these APIs with dozens of third-party partners, and we've had some really great apps be created. You've seen several of them featured in the keynote. You've seen several of them in previous sessions. I'm going to walk through a couple more here just to give you an idea of the types of things that are now that are now possible with this SDK. So Runtastic is a social fitness platform, and their Wear integration helps users control those sessions from their wrist. So you can say, okay, Google, start running, and they'll post a notification to that stream that has a running timer of your current run. They can also show new UI inside of these cards with a new platform feature called Display Intents that allow you to embed an activity directly into these cards for drawing your own UI. On the right here, we also see a piece of data that was generated on the phone, which is your route that can be synchronized across automatically, and we'll go into the details of how you do that. Another example, Philips Hue. They are connected light bulbs that allow you to change their colors from your phone. There's a display out on the third floor here, really fantastic. Or maybe it's down on the second floor, sorry. And what their app does is when you come home, it posts this contextual card to the stream that allows you to then control your lighting. They also can launch a full screen activity to draw their own UI to have a more immersive experience while you're controlling that app and then get back to the stream. So important to note here is that we're really focusing apps around micro interactions. So we want users to be able to get into your feature, complete a task, and then get back to that stream as quickly as possible. If there's an action that requires deeper integration, we want to forward that user back to the phone. We've also made that very easy for you. One more example here, Glimpse, which is a social location sharing application. So you can send your location to your friends. On the wearable, we can send contact information from your phone across so you can have a list of contacts to look through to be able to send those locations. When you receive a Glimpse, you can also then see in real time the progress of your friend coming to you. So let's take a look at what we're going to be looking at for the rest of the talk here. So Justin just got this adorable new puppy. And so we've built a little slide control app here for showing some pictures of that puppy. So we've got a phone and a wearable up here. When we start on this slideshow, we can post a notification to the stream on the right here. As you scroll through the view pager on the left, we're updating in real time on the right the title of the slide as well as the number of the slide. We also have an action that allows you to go backwards. Tapping on that first piece also allows you to advance the slides on the phone. So we're using it as a remote control, and we're using all of these new APIs to provide a seamless experience across both devices. So if we take a look at what it takes to build this application, when we write an app for a phone or tablet, typically we have one APK per app. But with Android Wear, we're extending that concept to expand across both devices. So we have an APK that runs directly on the phone, and we have an APK that runs directly on the wearable that are both part of your app. Google Play Services is what brings these two things together, and where we're going to talk about a new set of APIs that allow you to send data between the two and facilitate that communication. So the wearable services consist of three APIs: a data API, a message API, and a node API. These are both callable from either side, so from the wearable or from the phone. And all of your data is private to your application across the link. So if we dig into here first and look at the node API, this is used for discovering when nodes come into and out of a connected state. So when we have a pairing established between a watch and a phone, for example, we can be notified when we come into connection range. So you might use this in your app to know when a wearable is present, to toggle features on and off. We might display an icon to show that you're connected to a wearable. It's a very simple API for just being aware of when the wearable is present. Built on top of that is the message API. So this is a low latency mechanism for sending byte arrays back and forth between the devices, and they can be filtered on paths, which Justin will explain in detail later. So in the puppy example, when we are tapping on the card in the stream or tapping that back button to go backwards, we're calling send message to send a simple control back to the phone, which receives that message and then moves the view pager. The data API is the biggest piece of this new wearable service. It's a replicated data store. You can think about it as a shared cache. So we have the ability to put data into this and take data out of it, be notified when it changes on either side, and we take care of synchronizing that data between devices. So you don't need to worry about devices that are intermittently connected, what to do when you have extended periods of not being connected. We do all of the hard work there, and all you have to do from the app side is put data into the store and take it out. So in the puppy example, we might put the title of the slide and that slide number into the store. Google Play Services replicates that across to the wearable, where we can then update that notification in real time, so we can have the data sent back and forth there. So now I'm going to turn things over to Justin for a little bit, who's going to walk us through using these APIs and really dig into some of the code, which I know is you're all excited about. Take it away, Justin.
Thanks a lot, Austin. Whoa, a little drinking problem there. So you'll have to excuse me. We just got our new puppy, and I'm incredibly allergic to her, so I've developed a bit of a cough. So if you see me about to go like this, everyone kind of earmuffs. So let's take a look at the overall building blocks that are going to make up our application. On the left-hand side here, we have our view pager that's going to have a couple fragments, these slide fragments. And when the user slides from left to right, we're going to update our data item. We're going to update the index from 1 to 2. We push this into the data store, and that event is going to get over to the wearable, and we're going to update a notification when that happens. So to begin, we need to download Android Studio and create a new project. So I've created a new project here called Slide Control. You can see that Android Studio now supports multiple form factors, all the form factors that we talked about yesterday. Where is one of those? So you just click the checkbox here, and Android Studio is going to take care of packaging up this glanceable portion of your APK, or this watch APK, into your phone application so that it can be distributed through the Play Store. Let's start by setting up the phone UI. So like I said, this activity is a view pager, and it has a couple fragments in it with the background image titled The Slide. And these are all the files that make up the two different applications. Again, on the left, we've got the phone APK files in green. On the right, we've got the wearable APK files in blue. Let's take a look at the presentation activity. And this is the view pager one. And we can see that the first thing we need to do is to create a Google API client. That's your entry point into all of these Google Play services. So the new API here is the wearable API. So I'm going to build my client and stash it away somewhere so I can use it throughout my application's lifecycle. Next thing I want to do is wire up my view pager so that when those events happen, we can update the data store. And I do that by creating an on-page change listener and calling update data item. Let's take a look at data items. So like we said, URIs are everything in this data API. And we do that because it's really easy to create them and parse them using existing Android classes. So in this case, I am creating a data item that's going to manage the state. What is the current index and the current title of the presentation slide that I'm on? So I create this /state path, and internally, the data API is going to create this fully qualified URI, where, // node ID, and state. Now, you don't have to worry about that as much as developers. You can just worry about the paths, et cetera. But knowing that this is the format of the URI will help you later when it comes time to reconstitute these URIs on the other side. Data items are byte arrays at their base, but we know that working with byte arrays can be, not that flexible. It's really nice to be able to work at the key value pair level, like a bundle. So we've created a key value pair object called the data map, which stores primitive types. Unlike a bundle, we won't be storing anything like parcelables or binders in there because this item is going to be sent to all the nodes in our network. So in this case, I create a data map, and I'm going to put in these primitive types, the current index, the total number of slides, and the title of the current slide we're on. Finally, I just insert it into the store, and it's going to get synchronized to all of the connected nodes. On the wearable side, we want to be able to receive this, and we want to be running a service to do so. Now, we don't want all the different applications to have to be running constant services all the time just to listen for a message. And so what we've done is we've created this abstract class, the wearable listener service, which implements all of the different callback methods that you're going to be using with these wearable APIs. That's node listener, message listener, and data listener. So I've subclassed this here in a presentation listener service, and I just insert that into my Android manifest. By doing so, the Google Play Services APK is going to manage the life cycle of this service for me, so it's not always running and consuming resources, precious resources, on my wearable. Let's go over here to presentation listener service. And you'll see that the data listener interface has one method, onDataChanged. When I get that, I'm going to check the path because there may be multiple messages in my application. And I want to make sure I'm doing the right thing with the right data method, with the right data item. So if the state, remember we set this up as the state, is the data item's path, then I'm going to either create or update the notification if it's just being changed. And if it's being deleted, I want to remove that notification from the stream because it's no longer relevant to the user. In handle state changed, we're going to extract our data map. We're going to get all of those primitives out of there, and we're going to post our notification. Now, I know this is a lot of code. We're going to walk through it step by step. What are the things that we want to do? We want to get an intent back into our service when the user taps that first card. So to do so, it's just like Android. I'm going to create a pending intent to our service, and I'm going to use an action on this intent to determine what the user wants to do. Do they want to advance the slide, or do they want to go previous? Next thing I'm going to do is create a notification manager compat object, which is in the support library. So building this basic notification is just like building a notification on the phone. I've got my title, I've got my text, and like Austin said, we're going to set ongoing because this represents an ongoing process. Finally, we're going to augment or extend our notification with the new APIs that exist in the support library. So I'm going to create a new action, which will be the advance action. By default, if I were to have created a content intent, on Android Wear, we would render this as a blue circle. But if you notice from the demos, we wanted to be able to just tap the card and advance the slide. So I've created my action here with a drawable and just some text. And I've called set content action. That's going to hoist that action onto the card. And if you remember from the design talk that you may have seen, Designing for Wearables, we're going to want to make that icon blue so that the user knows that they can tap the card. That's going to be the signal. When they see blue, that's an actionable thing. Finally, we extend our builder, and that's going to create that notification that you see. Now, of course, with even more code, we can add in the previous action. We just create a different intent with a different action, on the intent, and then we create a different action on the notification itself. So as a reward for getting through all that code, here's a picture of a puppy. So on the phone side, we're going to want to receive some messages. So first of all, we have to send the message. So in this case, we're going to see that I'm going to tap on the previous slide button, and it's going to go back there. And that's still going to be in presentation listener service. Remember, when that pending intent fires, it's going to come back into our service. And check what is the action of the intent that came in. I'm going to just send a control message using the message API. So I take a Google API client where I've added the wearable API, and I'm just going to send 1 byte. So it's either going to be 0 to go forward or 1 to go back. And I'm going to send this to a specific node, the node that owns the data item. Remember, I can get this by parsing the path of the data item. And I'm going to send this on its own specific path, which we're going to call the control path. Over on the phone side, we make view presentation activity also implement a message listener interface. That means that it's going to implement this on message received. So if it is a control message, we just take that first byte and we decide whether we're going to advance the slide or go to the previous slide. When that happens, we update the view pager. We just call set current item on the view pager. And then that's going to fire the on-page change listener, which will update the data item and come all the way back around. So this is a really good pattern. You want to make sure that your data items are sort of owned by one of the nodes in your system. In this case, the data item is owned by the phone. We could have tried to edit it on the wearable side and have that synchronized back and forth. That gets a little messy. It's much better to do, data item owned by one of the nodes, and then you send messages to update it, and then you just have this virtuous cycle going round and around. So as we see here, when we get our message, we are going to just go back to the previous slide. So let's talk a little bit about extending this use case. Now, if I'm giving a longer presentation, it might be good to have this notification in the stream. I want my watch to be able to time out back to the home screen, so I'm not burning power. But if we're giving a much shorter, more condensed presentation, I would maybe want to control what activity is on top so that as a user, I can just kind of slide around and not really have to worry about what I'm doing. And to do this, I'm going to create a custom activity that's running on the wearable. Let's take a look at that. So in this slide we can slide over, and we have another action here called the full screen. And when I tap on it, I'm going to bring up an activity on the wearable that has a view pager. And these are synchronized. So when I swipe over here, it's going to update the view pager running on the phone. It also has some other things that I might want for my presentation, like the current time, and maybe I want to go red when I'm going overtime or things like that. So let's talk about how to get this data, the image and the titles, over to the wearable. We want to use the data layer. We want to do it efficiently. We could just keep updating our state data item, But that means that every time it changes, we're going to have to send all that data over and over and over again. So instead, I'm going to store my data in several data items, and they're each going to have their own unique path. So it's going to be where, // the node ID, then slide / the index. And so you can see here I've got 3 different data items. And over here on the wearable, I use that to inflate some card fragments for my activity. We're going to call this the slide control activity. So let's see how we do that. In our slide control activity, we have a very simple layout. It's just a view pager. But remember, I want to make sure that this doesn't time out to the home screen. And I do that by setting Android keep screen on to true. Again, just like you would do on a phone if you had some sort of media playing application. Now, remember, with great power comes great responsibility. You want to be kind to people's batteries. You don't want to be in a situation where the user might accidentally end up in this full screen activity and it doesn't efficiently go to sleep. So we want to watch out for, with keep screen on, you probably want to keep track of the user's timeout. If you might want to make it settable, and if the user hasn't interacted with the device for a certain period of time, just finish your activity. We also want to key activities to a user's context. So remember, with presentation listener service, when the user's finished viewing the slideshow on their phone, we remove the notification. Similarly, when the user's finished viewing the slideshow on their phone, we also want to exit this activity if it's running. And the final note is to watch out for wake locks. It's very important on wearables with the smaller battery capacity to just really be cognizant of your user's batteries. So let's take a look over here in slide control activity. And we've set this up very much like the presentation listener service. So we've got our handle state change method here. We're going to extract our presentation data, and we're just going to set the view pager that's running on the wearable to be the same index as the index on the phone. We also want to be able to control it from the wearable. So I create another on-page change listener, and now I'm going to send a different type of message. Instead of that control forward and backwards message, I'm going to send a new type of message on a different path called slide. And here the byte is just going to say, what is the desired index that I want to have? Back on the phone side, in the view presentation activity, if I see the message coming in on the slide path, then I'm going to parse that out from the byte, and I'm just going to set it there. Once again, I will then trigger the on-page change listener, which will trigger update item, and everything goes around. Virtuous cycle. And here we see the results of that. There we go. So by default, Android Wear activities can be dismissed by swiping left to right. This even works with our view pager. If we swipe over a few times and swipe back, everything works the way you expect. When I'm on the first slide, if I swipe from left to right, I'm going to dismiss that activity. But remember, I'm in the middle of a high-stakes presentation here, and I don't want to accidentally do that if I'm moving around. So when we want to override that behavior, it's definitely possible. And it's possible without a line of Java code. It's just updating a style and your Android manifest. So we come over here, and you create a theme in your application that inherits from the device default theme. We're still running KitKat on the wearable, and so we don't have these material themes yet. So we're theme device default. You should definitely use those in your applications. We have a new attribute here called Android Window Swipe to Dismiss. By setting this to false, you're going to disable that default behavior of being able to swipe an activity away. Then I just set that as my theme in the activity. Now, I don't want the user to get locked into my activity, though. They should know how to get out. By default, all Android Wear devices, you can put your palm on the screen to go back to the home screen. But that's not necessarily as elegant as we'd like to do. We'd like to establish a pattern for these full-screen applications. And what we've come up with is a long press. So when you long press, we're going to bring up this red circle. And then if you tap it, we're going to finish the activity. We've created a support class to make it very easy for you to do this in your own applications. So I'm going to update my layouts, and I'm going to create a dismiss overlay view. So that just hangs out on top, and it's going to be hidden by default. Over here in slide control activity, I just need to get a reference to that overlay view, and then use a gesture detector. I could have used a long click listener if I had a different type of view, but with View Pager, it's easier to use a gesture detector. So again, just like using it on the phone, create a gesture detector. I'm going to feed motion events to it, and when I get the long press, I'll show my dismiss overlay view. Dismiss overlay view is going to take care of everything else. When the user taps on it, it's going to exit the activity and go back to the stream. Final thing we want to talk about are assets, getting picture data over to the wearable. Obviously, that's what we're going to want to do to create these rich, awesome experiences for our users. So everything that we're doing is in the name of efficiency. Efficiency for battery power, and, for battery life, et cetera. So let's say I had an app that used a contact photo. That's a very common use case. And say that somebody else wanted to use that exact same contact photo. Well, we don't want to have to transmit multiple copies. So by putting these assets into our data layer, we will take a hash and only send one copy over. Now, on the other side of the link, these applications don't really know that another application was using that same asset. They just see it as their own private copy. So it's all secure, it's all there, it's great. We're going to use those assets with our puppy app, although who else is going to be using pictures of my puppy? We're going to want to not send the full resolution image over, however. So the resolution on the Nexus 5 is much higher than the one on the wearable. So I'm going to want to make sure that only I'm sending the image data that's necessary for display on a smaller device. So to do that, we go into View Presentation Activity. And here, we're going to call this function for each of the slides in our presentation. I'll probably do this in an asynchronous task when I'm loading it up. I'm going to create my data items at a known URI, so in this case, slides/index. I'm going to put the title in, and now I'm going to create an asset. All of my slide objects know how to create a smaller version of themselves, just as a byte array. From there, I send that to asset create from bytes, and I put it into the map. And then it's going to intelligently send that over to the wearable. On the wearable side, in the slide control activity, let's see here. I'm going to, again, use an asynchronous task or a loader to load this up. And here's where we see the importance of the paths. Since I know that it's going to be where, : / et cetera, I can send these URIs around and build upon them in order to derive queries for these data items. And so here I'm going to load up each of the different data items from the data layer. I'm going to extract the asset. And from those bytes, I'm going to create a bitmap that I can then use to update my UI. And that's what we got. So now I'm going to turn it back to Austin.
All right. Thank you, Justin. So we hope that's given you a taste of what's possible with these new APIs and with this new form factor, and has sparked some ideas for your own apps or maybe even new apps. So we're all very excited to see what you go and create. For more information, you guys can visit developer.android.com/where, download the SDK, get started there. There's an emulator. You can use it with the devices that you've got at the giveaway, and you can get started there. We also have even more information about these APIs available as IO bytes. Those are up on YouTube right now. You can go check them out. And with that, we will thank you, and we'll take questions. There's microphones right in the aisleways here. Thank you. Yes?
Yeah, you mentioned, I thought you mentioned that the wearable leverages the Google Play services. So does this mean that we can't connect to like Kindle devices and that kind of thing?
So the connection is driven by Google Play services. So we are compatible with any Android device running 4.3 or greater with the Play Store.
Thank you.
Let's go to the side.
Hi. Is it possible to leave your custom activity on and let the device go to sleep? Or does that automatically exit to the home screen when the the wake lock is released?
It's going to automatically time out after 30 seconds to the home screen.
Gotcha. So there's no way to just leave the app on, like say you're doing a presentation and you want to let it go to sleep while you're talking, and then you open up and then you want to swipe again.
So that's where you would probably use the notifications that we showed in the first part of this.
Oh, gotcha.
Yeah.
Gotcha. Okay, great. Thank you.
Over here.
You guys talked about the watch as basically just a remote control and the UI, but what about when the watch is providing like gyroscope or movements and heartbeats and things like that? How are you dealing with sensors?
So remember that it is Android running on this wearable. So you register a sensor listener for the type of sensor that you want to consume, and then remember that these APIs are callable from both sides of the link. So you can collect sensor data on the wearable and then send it to your instance of your app running on your phone.
So, you mentioned that you can install discrete apps on the phone themselves, right? So how do you switch between app to app? Where's the menu, if you will, or where's the listing of all the apps that you have on your phone?
So the UI is really designed to be post-grid. So it is intentionally missing that grid of apps. So we encourage developers to think about putting cards into that stream when they're relevant or to register for voice actions. You can also say, OK, Google, start app name, and be able to bring that application up on demand. You can also get to that through